All right, so we're starting our second page of the review. So what we're going to do is rewrite without rational exponents and simplify if possible. So what we're going to do here, so let's just say you had something like x raised to the power of a over b, okay? So the numerator right there tells you to take the a root of x and then raise it to the power of b. You can either put the b on the inside. I typically put it on the outside, but you could put it on the inside too. But there's advantages to doing that sometimes, but for the most part, we're going to put it on the outside. So looking at our first one right here, so we have 8 raised to the 2/3 power. So the 3 is going to be the index of the radical. So it's going to be a cube root of 8. And then after you cube root it, we're going to square it. So the cube root of 8 is 2. And then we square it, which is 4. And there you go. Okay, so then on the next one, we have a negative exponent. So just like properties of exponents from unit 1, you have to take the reciprocal in order for that exponent to become positive. So we do that. And then now we go ahead and convert it to radical form. So this is going to be 1 over, so the denominator is a 2, so we're going to do a square root. You could put a 2 there if you want, but it's not necessary. And then we're going to cube that result. All right, so the square root of 16 is 4. And then we cube it. So then we're going to get 1 over 64. There you go. All right, so we got one left like this, very similar to the previous one, except this time we put the negative with the base. So what's going on though here is it's really negative 1 times 9 to the 3/2. So really that negative 1 gets multiplied at the very end. If it were in parentheses, it'd be a different story, and there'd actually be an issue with the problem. But there's not parentheses, so it's going to be applied afterwards. So we'll go ahead and do our conversion. This becomes the square root of 9, and then raised to the power of 3. So then now we're going to have negative 1 times, let's see, the square root of 3 is 3, and then raised to the 3rd power. So we get negative 1 times 27. 3 to the 3rd power is 27. So then when you multiply it by negative 1, you get negative 27 right there. All right. So that's that part. Okay. So as I come down, you can see that from the directions, I lifted this straight from the exam. I just kind of changed, obviously I changed some of the numbers, but really this is basically what you can expect on the exam, which you're about to see here. So simplify the expressions using properties of radical exponents, okay? I'm sorry, rational exponents. Write the final answer using positive exponents only. So that you've done this before, you just haven't done it with fractions until this unit. So we know all the rules, okay? So here is the product rule. When you multiply, you add the exponents. So this is going to become x to the 7/3 plus 2/3, okay? And so when you add that together, you've got your common denominator, so that makes life pretty easy. So it's going to become a 9 over 3, which then we can just reduce that down to x to the power of 3. That is it, okay? You've done stuff like this before, just haven't had to do it with fractions till now. Not that big of a deal. Just 7 plus 2 is 9. 9 over 3 reduces to a 3. Now the power rule, power to a power, you're going to multiply these. So what's going to happen here is you're going to multiply 4. I'm going to go ahead and put 4 over 1 times 9 over 2. And I do that just to kind of help me as I start trying to reduce. So what we're going to do right here is this 2 reduces with this 4 down to a 2. So really my denominators are 1s, so I don't really have a fraction any longer. I just have 2 times 9, so I'm going to get x to the 18th power. And there you go. Okay, and then on our last one here, what we're going to have to do is do the product rule first and then do the quotient rule in a second, okay? So what we're going to do here, we're going to go ahead and add those. So let's see, we're going to have 10 over 5 plus negative 1/5, and so I'll go ahead and write that out. So we're going to have 10 over 5 plus negative 1/5 all over x to the negative 2 over 5. Okay, so we can go ahead and add this together up here. So that's going to give me x to the, let's see, it's going to be 9 over 5. And then on bottom I have x to the negative 2 over 5. And so now we're going to have to do the quotient rule. And so the quotient rule is that you subtract the exponent from the denominator from the numerator. So this is going to become x to the 9/5 minus, and then it's going to be a negative 2/5. So I'm actually going to have a double negative here. And what's going to happen is I'm actually going to end up adding those together, and I'll go ahead and write that out though. So let's see, I get 9/5. The double negative turns that into a plus 2/5. And so when you add that together, you're going to get x to the 11/5. And there you go. That's your answer for part C. Okay, so the last part of this page here is going to be basically adding and subtracting radicals, and the only way you can do that, is if they have the same, it's known as the radicand, so they have to have the same value inside the radical in order to add the coefficients. So if you look at the first one, you have an 8 and a 50, so obviously they're not the same. But you could probably manipulate each one of them and end up having a common one. So my advice is just kind of start with the first one. Just kind of forget about this for a moment. Let's just focus on simplifying this. And so if you look here, we can break this apart into the square root of 4 times the square root of 2, right? That's what I broke the 8 up into. And then I can go ahead and evaluate the square root of 4. So I'm going to get 2 times 2. Oops. 2 times the square root of 2. A lot of 2's there. Okay. And so then when you clean this up, 2 times 2, that gives us a 4, and then that last 2 is still inside there. Okay, so now if you look at the other part of it, now we're going to kind of clean this up, and we should end up with something that we can actually go ahead and finish the operation. So we have 3, and then I'm going to break up 50 into the square root of 25 times the square root of 2. Okay, so then 25 I can go ahead and evaluate, simplify into a 5. So 5, sorry, that's a little messy. And then square root of 2. And then when we multiply that together, we're going to get minus 15 square roots of 2. All right, so now they have the same radical. So what's going on here, you don't have to take this extra step, but I just want to make sure it's clear. Basically what I can do here is I could factor out that square root of 2, and then I could focus on the 4, take away 15, which is negative 11, and then we have square root of 2. And there you go. Okay, so the others are going to be basically done the same way. So if we look at 56, so you've got 8 times 80 is going to break up into the square root of 16 times the square root of 5. And I'm just going to go ahead and finish simplifying this before I even work on the other one. So this will give me 8 times 4 times the square root of 5. 8 times 5 is 32, square root of 5. Okay, so once I play around with this one, I'll probably have something similar to where I can go ahead and subtract. So let's see, so starting on the first part, we'll break that up into a 9 and a 5, so we break the 45 up into 9 times 5. Then we can go ahead and we can go ahead and take the square root of 9. Okay, so let's see, there we go. That's going to give us a 3, and then you have the square root of 5 right here. So we can go ahead and multiply those 3's together, so that's going to give us 9, and then we have square root of 5. And then once again, like I did on the previous one, what I'll do is I'll go ahead and factor out that common radical. So we end up with 32 minus 9, and then square root of 5 right here. So let's see, 32 take away 9, let's see, that's going to be 23, and then square root of 5. Okay. Last one, pretty similar. You'll notice they both have a variable of y inside there. Won't really be able to do much with that, okay? But the 27, I can kind of break that apart. And in front, that's an understood -1. So what's going to happen here on the first one? So I get -1, and then times, I'm going to break that up into the square root of 9 times the square root of 3y. So I got the 3y right there. So 9 times 3y is 27y. But I broke it up so I can go ahead and square root the 9. So I'm going to get -1 times 3 times the square root of 3y. So this all simplifies to -3 square root of 3y. Okay, now on the second one, kind of similar, I'm going to break up that 75. So I can break that up into a 25 times the square root of 3y. So 25 times 3y would be 75y. But we want to leave it like this so I can evaluate that part right there. So that's going to give me 2 times 5, and then times the square root of 3y. And so then 2 times 5 is 10, so I'm going to have 10 square root of 3y. And then once again, what I can do is factor out that square root of 3y. So I'm going to have -3 plus 10. And I'm factoring out the square root of 3y. And then so -3 plus 10 is 7. And then I have square root of 3y right there. And that's what we're looking at. And that's it. All right, one page to go.